Hello students, myself Varikar Ain from SGM College Karan. We already started a topic vectors. This is our fourth lecture. In last lecture, we studied some theorems on the vectors and examples on it. Now in this lecture, we studied first point, a distance of P of xyz from coordinate axis. Suppose there are three axes, x-axis, y-axis and z-axis. And this is a point P in a space x, y, z. We draw a planes which join these coordinate axes. Then what is the distance? First, distance of P from xy plane. Distance of this point P from xy plane. Xy plane is here. So this distance is this PL, that is the perpendicular PL. So length of PL, which is equal to Z, because this PL is parallel to Z. So this is mod of Z. So this is the distance of a P from XY plane. Then next is distance of a P from YZ plane. What is YZ plane? This is a YZ plane. So distance of a P from YZ plane, that means this PM, perpendicular PM, which is equal to mod of X, because this is parallel to this X. Then third, distance of a P from XZ plane. This XZ plane, the distance, this is the perpendicular PN. So mod of PN, which is equal to mod Y. Then distance of a point P XYZ from origin. The distance of a point P XYZ from origin is distance is equal to root of x square plus y square plus z square. The distance between any two points in a space. Remember this formula, distance of a point from the origin. Just make a square of these coordinates and add it and find the square root of this. Then distance between any two points in a space. The distance between two points. Suppose there is a one point is x1, y1, z1. Another point is x2, y2, z2 in a space. Then by distance formula, which is equal to square root of x1 minus x2 bracket square plus y1 minus y2 bracket square plus z1 minus z2 bracket square. This is a distance formula. That means distance between two points. Then distance of a point from coordinate axes. These are the coordinate axes x, y and z. And distance of this point from this coordinate axis, we have to find distance of this point from the coordinate axis. So distance of a point P from x-axis. This is a point P. And from x-axis, this distance can be calculated by root of y square plus z square. Then distance of a point from y-axis, which is equal to root of x square plus z square. Then distance of a point P from z-axis, which is equal to root of x square plus y square. In these three formulas, we observe that if distance of a point from x-axis, here x coordinate is missing. Here distance from a y-axis, then y coordinate is missing here in this formula. So, and distance from a z-axis, here z coordinate is missing. So, this is simple to understand and to remember. These three formulas. Then, next is theorem fourth. I repeat my sentence, that is the theorems which is belongs to this topic are very, very important theorems for the board examination. This is our fourth theorem. If A bar, B bar, C bar are three non-coplanar vectors, then any vector R bar in the space can be uniquely expressed as a linear combination of A bar, B bar, C bar. That means we have to prove that r bar is equal to, suppose there are x, y, z are the scalars, then r bar is equal to x a bar plus y b bar plus z c bar. We have to prove this. R bar is equal to linear combination of these three vectors. So firstly, we consider a point A in a space. A is any point in a space. We draw three. We take a four vectors A bar, B bar, C bar, and R bar in such a way that A becomes their initial point. That A becomes their initial point. Suppose AP bar, this AP bar is equal to R bar, and these three A bar, B bar, C bar are non-coplanar vectors. They determine the distinct planes. They has a distinct planes, but they are intersecting. These three planes intersecting at point A. Intersecting at point A. Then draw the parallel planes to these three planes. Draw a parallel to this plane, this. Draw parallel to this plane, this is, and draw parallel to this plane, this, and it completes the parallelogram, a parallelepiped. It completes the parallelepiped. This diagram becomes into a parallelepiped. Then AB bar and A bar are collinear. This is AB bar and A bar are collinear. Why this is collinear? Because A bar is along with AB bar. So AB bar and A bar are collinear. And if two vectors are collinear, then one vector is equal to scalar multiple of other. Suppose X is the scalar, then AB bar is equal to what? XA bar. Then consider AQ bar. AQ bar is along with B bar. AQ bar is along with B bar. Then AQ bar and B bar also collinear. And if these are collinear, then AQ bar is equal to scalar into B bar. Suppose that scalar is Y. Similarly, AS is along with C bar. So AS bar is collinear with C bar. So AS bar is equal to scalar into C bar. That scalar is Z. Then in triangle ACP, in this triangle, by triangle law, AP bar is equal to AC bar plus CP bar. AP bar is equal to AC bar plus CP bar by triangle law. But what is in triangle ABC? Look here, in triangle ABC, in this triangle, AC bar, what is AC bar? AC bar equal to AB bar plus BC bar. So, the behalf of AC bar, we write here AB bar plus BC bar. So, AP bar is equal to what? AB bar plus BC bar plus CP bar. And what is AB bar? AB bar is XA bar. Now, BC bar. BC bar is parallel to AQ bar. BC bar is parallel to AQ bar, or it is similar to AQ bar. So AQ bar is equal to YB bar. So here YB bar. Then CP bar. What is CP bar? CP bar is here. This is equal to AS bar. This is equal to AS bar. So what is AS bar? AS bar is equal to ZC bar. So here ZC bar. So R bar is equal to XA bar plus YB bar plus ZC bar. What is this? This is the linear combination. Scalar into vector, scalar into vector, scalar into vector. So we expressed R bar as a linear combination of A bar, B bar, C bar. Now we have to prove that uniqueness of this theorem, that scalars are unique. So what is the uniqueness? Suppose R bar is equal to x1, x2, x3 are scalars and y1, y2, y3 are another scalars. Then R bar is equal to x1a bar plus x2b bar plus x3c bar, and R bar is equal to y1a bar plus y2b bar plus y3c bar. Now we need to prove that x1 is equal to y1, x2 is equal to y2, and x3 is equal to y3. Now subtracting these two equations, what we will get? Here R bar minus R bar 0, x1 minus y1 a bar, x2 minus y2 b bar, x3 minus y3 c bar, which is equal to 0 bar. Then from corollary 1, which is belongs to theorem 3, corollary 1, what we will get? Suppose x a bar, what is that corollary? Suppose x a bar plus y b bar plus z c bar is equal to 0 bar, then x is equal to 0, y is equal to 0, and z is equal to 0. This is the corollary. So as a bar, b bar, c bar are non-coplanar vectors, then these scalars are 0. That means x1 minus y1 is equal to 0, x2 minus y2 is equal to 0, and x3 minus y3 is equal to 0. That means x1 is equal to y1, x2 is equal to y2, and x3 is equal to y3. And this is the uniqueness of this theorem. Then the notes. These notes we already studied in last lecture. If a bar is equal to a1 I cap plus a2 j cap plus a3 k cap, and b bar is equal to b1 I cap plus b2 j cap plus b3 k cap, then a bar is equal to b bar if a1 is equal to b1, a2 is equal to b2, and a3 is equal to b3. This is very simple note. Then if a bar is equal to this vector, b bar is equal to this vector, then a bar plus b bar, we add the coefficient, corresponding coefficient, that is a1 plus b1 I cap, a2 plus b2 j cap, a3 plus b3 k cap. Then if we multiply any vector to the scalar, then we multiply each and every term to that scalar. If b bar and a bar are collinear, b bar and a bar are collinear, then b bar is equal to scalar into a bar, then b1 upon a1 is equal to b2 upon a2 is equal to b3 upon a3. That means the ratio of their corresponding coefficients are a constants, is equal to a constant. This is a very important note. Then suppose a cap is a non-zero unit vector along the vector a bar, then a cap is equal to that vector upon its magnitude. These are the notes. This note is collinearity of 3 points. Suppose A, B, C are 3 points and their position vectors are A bar, B bar, and C bar, and they are collinear if and only if x A bar plus y B bar plus z C bar is equal to 0 bar, then x plus y plus z is equal to 0. This note is very important for JEE. These two notes are important for JEE and CET examination. Remember these two notes. That is x A bar plus y B bar plus z C bar is equal to 0 bar, and x plus y plus z is equal to 0. Then these points are collinear. Then coplanarity of 4 points. 4 distinct points A, B, C, D, but no 3 of which are collinear, with position vectors A bar, B bar, C bar, and D bar are coplanar. These are the coplanars if and only if x A bar plus y B bar plus z C bar plus w D bar is equal to 0. That means their linear combination is equal to 0, where x plus y plus z plus w is equal to 0. Their addition is equal to 0. This is coplanarity of 4 points. Then these 2 points are also important for the JEE and CET examination. These 2 points are very important for JEE and CET examination. What is that? Linearly dependent vectors. Linearly dependent vectors. Suppose there are 3 vectors A bar, B bar, and C bar, and these 3 vectors are said to be linearly dependent if there exists a scalars x, y, z not all 0 such that x A bar plus y B bar plus z C bar is equal to 0, and such vectors are coplanar vectors. Such vectors are coplanar vectors. Then we say that A bar, B bar, C bar are linearly dependent vectors. And what is linearly independent vectors? A set of non-zero vectors A bar, B bar and C bar is said to be linearly independent if their linear combination is equal to 0, then x is equal to y is equal to z is equal to 0, and such vectors are not coplanar vectors. These are the coplanar vectors, and here these are the non-coplanar vectors. This is linearly dependent, this is linearly independent. Look at the difference between these two. Linearly dependent and linearly independent, not all zero, and here all zero. And here this is coplanar and this is non-coplanar. Then next example, find the distance of 4, -2, 6 from each of the following. First, xy plane, zx plane, y-axis and x-axis. Suppose there is a point A, its coordinate is 4, -2, 6. So point A, the distance of A from xy plane, its formula is magnitude of z, which is equal to directly 6. The distance of A from zx plane, which is equal to y mod of y, so -2 becomes +2 because distance is never negative. So distance of A from y-axis, which is equal to root of z square plus x square, so 6 square plus x, that is x is 4, so 4 square, which is equal to 2 root 13. Then the distance of A from x-axis, which is equal to root of y square plus z square, y square is -2 square, z is 6, that is equal to root 40, which is equal to 2 root 10. Then next example, find the coordinates of the point which is located A point 3 units behind the YZ plane, 4 units to the right of XZ plane, 5 units above the XY plane, and second B is in the YZ plane, 1 unit to the right of the XZ plane and 6 unit above the XY plane. So solution of A. Let the coordinate axis or the coordinate of the point is x, y, z. Since the point is located 3 units behind the YZ plane, 4 units behind the XZ plane, and 5 units behind the XY plane. That means x is equal to -3, y is equal to 4, and z is equal to 5. Here behind the YZ plane, so it will be -3, and it is right of and it is the above of, so these two have a positive sign and this has a negative sign. So coordinate of this point is -3, 4, 5. Then B, if the coordinate is xyz, then since the point is located in the YZ plane, so if it is in a YZ plane, so x is equal to 0, obvious. 1 unit to the right of the XZ plane, 1 unit to the right of the XZ plane, and 6 unit above the XY plane, 6 unit above the XY plane. So XZ plane, right of the XZ plane, so it is positive, that is y is equal to 1, and above the XY plane, so it is also positive, so it is 6. Hence coordinate of axis, coordinates of the required point is 0, 1, 6. Then find the area of a triangle with vertices 1, 1, 0, 1, 0, 1 and 0, 1, 1. Let A is equal to first coordinate, B is equal to second coordinate, and C is equal to third coordinate. We have to find the area of the triangle. For that, we find the length of this triangle. So length of AB, by distance formula, we find the length of AB, which is equal to root of x1 minus x2 bracket square, y1 minus y2 bracket square, z1 minus z2 bracket square. It is root of 0 plus 1 plus 1, which is equal to root 2. Then length of BC, similarly we find length of BC, we use the distance formula root of 1 minus 0 square then 0 minus 1 square, then 1 minus 1 bracket square, which is equal to root of 1 plus 1 plus 0, which is equal to root 2. Then length of CA is equal to what? Root of 0 minus 1 square, 1 minus 1 square plus 1 minus 0 square, which is equal to root of 1 plus 0 plus 1, which is equal to root 2. So length of AB is equal to length of BC is equal to length of CA. All these three lengths are same. That means this triangle is equilateral triangle. Then the area of equilateral triangle, which is equal to root 3 by 4 side square. Side is root 2. So root 2 square, which is equal to 2. That means root 3 by 2 square units. So in this lecture, we studied distances, theorem, and the example based on this point. Thank you.